shows that the acceleration of any object down a frictionless inclined plane that makes an angle theta with the horizontal is A equals G sine theta. So we're given an inclined plane, something like this, with angle theta, and the surface is frictionless, and we have an object on that inclined plane. Now, the best way to deal with such a situation is to align our x-axis parallel to the inclined plane and the y-axis perpendicular to it, like so. So we have positive x here and negative on this side, y-axis here and negative y is here. So the only force that we have under such a situation when the surface is frictionless is only the gravitational force. So now that gravitational force is straight downward, therefore it's going to be perpendicular to the base. Alright, so what will this angle be? Because we know the sum of all angles of a triangle is 180 degrees, angle alpha will be complement angle of theta, or let's show it like alpha equals to 180 degrees minus 90 degrees plus theta. Therefore 180 degrees minus 90 is 90, and we have a negative sign here, therefore theta will be negative. So alpha is 90 degrees minus theta. Now we know that the vertical axis and the plane make 90 degrees because the vertical axis is perpendicular to the inclined plane. Therefore we know that this one is equal to 90 degrees. This whole thing is 90 degrees. So what is this angle going to be? Let's call it phi. So phi is going to be 90 degrees minus alpha. But we know what alpha is. Therefore this is going to be 90 degrees minus 90 degrees minus theta. Alright, so 90 degrees minus 90 degrees is 0, negative here and negative here, negative times negative is positive, therefore this is going to be theta. So phi is equal to theta. We can just rewrite it, and this will be theta. So now we have mg downward, therefore the vertical component of mg is going to be alright, this will be the vertical component that's perpendicular to the plane, and it's equal to minus mg cos theta, simply from trigonometry. What about the parallel component, parallel to the inclined plane? That will be this line here, and its value will be mg sin theta, again from trigonometry. So now, because we have mg cos theta downward on the inclined plane, there will be a normal force acting on the object by the inclined plane, and this will be this value here, and this is a normal force. Normal force is opposite to mg cos theta, therefore it's going to be positive mg cos theta. Now the two of them cancel one another. There is no motion in a vertical direction, so the only motion we have is going to be along the inclined plane. That will be the translation of mg sin theta to the surface, with the frictionless surface. That's equal to mg sin theta. Okay, so the net force we have is equal to mg sin theta. and that net force from Newton's second law is mass times acceleration. Now we can divide both sides of the equation by m, and we get A is equal to g sine theta. And that's what we are required to prove.